diffraction and scattering mechanism. And after that, we had seen the ground reflection model or the two-ray reflection model with some basic equations and a relevant example. Uh, the Doppler shift. To the Doppler shift, we had seen an example of how taking place. Okay. So in today's session, we'll see the second part of your unit number 2, which is the multipath propagation. So I hope the screen is visible.
Yes, sir.
Yeah, okay, thank you. So part 2. Mobile communication. Part 2, the wireless channel. First of all, I'll give you an overview of the wireless systems that we are using in this second part. Then modeling, how do we model a wireless channels, the channel models and the statistical channel models, which comes under the time and frequency, the statistical channel models. We'll see all those things in this presentation. So first of all, let us start with the overview of wireless system. A small introduction to this presentation alone. So the wireless is a field that was evolved during 1897 with the successful invention by Marconi, wireless telegraphy. So in the forthcoming years, many types of wireless systems was being developed. Some got vanished also. Examples are your AM transmitters, FM transmitters, radios. Then came the wireless radio transmitters, the Akashvani channels that you are or your mother or your grandparents were hearing, all got vanished. Nowadays, it's being very familiar. Everything you can device, which we call as a mobile. So examples are your options. In earlier days, it was broadcasted by a wireless. Then after evolution, it was transmissions. Similarly, the point-to-point routes that were the backbone of the telephone network with optical fiber nowadays, where all the landline telephones usage are being removed off and they are being replaced by mobile phones, and the interconnecting networks are being fibers. I think you would be studying optical communication. So a major application or a major advancement nowadays, and this could be future. We are not sure about it. Okay, day by day. So the wireless technology became outdated when a wide distribution network was installed. The second, in network wide technology, optical fiber replaced the older technology. The cellular technology is partially the wired telephone networks, which has which has already been done also. The cellular telephones or the users in planes, in buildings, in streets, so in every part, everywhere, cellular telephone network users. So the cellular users were using a as we had discussed in Unit 1. So this fixed base were providing an area of coverage or network of coverage. So the area covered by a base station, that is the area from which reach the base station, is called as a cell. And often we use the region with the base station in the middle. Okay, simplified, which in each cell is hexagonal, like this hexagonal structure. In a more realistic case, when base stations are irregularly placed, so base stations are, and cell phones choose the best base station. So when a user makes a call, so this is what happens when you use a mobile phone. A user is a mobile who makes a call. It is connected to the base station, to which the base station area are then connected to the mobile telephone switching TSO, also called as mobile switching center, by high-speed wired connections or micro. Nowadays, optical fibers are replacing them. So this MTSO or MSC is connected to public wired telephone network. There's an incoming call from the mobile user is to the base station, and from there to the MTSO and then to the wired network. From there, the call goes to its destination, which might be an ordinary wireline telephone or might be another mobile subscriber. See that a cellular network is not independent network, but rather than dependent to the wired network also. Completely, it is not wireless. Then the MTSO plays a major role in coordinating the base station that handles a call from a user and handling handoff strategy also from a user to one base station or to another. So when another user places a call to given user, the place, what has been done would be in reverse. First, the MTSO for which the called is found out. Then the closest base station is, then the finally the call is set up through the MTSO and the base station. The wireless link from a base station to the mobile users is interchangeably called the downlink. Okay. From the base station to the mobile users, downlink or the forward channel, and the link from the users to the base station is called uplink or reverse channel. Keep in remembrance, is always the forward channel from base station to from higher tower antennas to the lower mobile users is called as the forward channel or the downlink. Whenever an user makes a call, so the link from the users or to the base station is called as reverse channel or the uplink. Keep in, so these are usually connected to base station. Many users will be connected to a single base, and thus for the downlink channel, the base station must multiply the signals to the various connected users and then broadcast one signal from which each user can extract its own. In the downlink, each user is connected to give a base station that transmits its waveform, and the base station will receive this users with the noise. So noise gets added up, eliminated. Then the base station should separate the signals from each user and signals to the MTSO. The oldest, such as the advanced mobile phone system, which was developed generation in United States in 1980s, So that is a voice waveform is modulated on a carrier and transmitted without being transformed into digital state. And uses in the same cell assign different modulation frequencies and different sets of frequencies as we had seen or discussed in unit 1. Currently are kept away from each other, and by using frequency reuse factor they are being kept apart. The a little knowledge of danger of interference. So then in the second generation systems are digital. Generation are digital where it used a GSM or CDMA systems as second part of unit number 1. So which consisted of the global system or mobile, which was standardized in Europe. Now it is being used worldwide. And IS interim standard 136 in US, and the IS multiplex was being developed in this second generation. Then the third generation came. The systems were designed to handle data and or voice. So higher rates data applications were being third generation. Many data applications are extremely bursty, so users may remain inactive for long periods of time but have demands for short periods of time. So in addition to voice was also being transmitted in the small mobile phones. So the voice had a tight latency requirement in the order of 100 microseconds. The data applications had a wide range of latency, like the real-time applications such as gaming, real such as gaming, file transfers, HTTP file transfer, all were being indulged. So broadcast systems like AM radio, FM radio, this were being into the mobile users, mobile phones or the cellular phones. Then smaller scale standards like ultra wideband communication or the ADAC network were being deployed in the third generation. So coming to the channels, a, a good channels is the key physical parameter that we are going to deal. So a defining characteristic of the wireless channel is that the variation of the channel strength over time and over frequency is classified into two, which is fading. Scale fading, which is due to path loss of as a function of distance and shadowing by larger objects such as buildings, hills, foliage, etc. As the mobile moves through a distance of the order of the cell and is typically frequency independent. Small scale, this is due to the constructive and destructive interference of the multiple signal paths between the transmitter and receiver. This at the spatial scale of the order of carrier wavelength and is these two we had seen in the first presentation, one presentation of unit 2. The physical modeling of the wireless channels on electromagnetic radiation from the transmitter to the receiver. Upon all this, 7 factors. One is free space propagation, fixed transmitter and receiving antennas. Next is free space propagation, moving antennas, which is are moving. Next is reflecting walls. Reflection principle is there. Reflecting as well as are being fixed. Next, reflecting with users moving or the antenna moving. Ground plane, so which you are seeing the two-ray model. Next is the power decay with the distance and shadowing. Moving antenna, multiple reflectors. So in the previous we had said about only the 3 reflections, which are a single reflections. So here antenna is moving and multiple reflections occur. The things which you are going to see. Okay.
The database management.
Hope somebody is attending database management class.
Yes, sir.
Okay, let us see. Let us see this model: free space, fixed transmitting and receiving antennas. So consider a fixed antenna which radiates electromagnetic wave radiation into wireless medium or into free space is fixing it at some points. Okay, so region, the electric field and the magnetic field application is perpendicular to each other, and the direction of propagation from this antenna to both E and H. So always when an electromagnetic wave propagates we will have electric field, we will have magnetic field, and electric field and magnetic field will be perpendicular to each other. And the direction of propagation of the electromagnetic wave to both E and H. We had studied in electromagnetic fields, so it is the same. So the direction of propagation of wave is perpendicular to both. So E is electric field, H is a magnetic field. So then they are also proportional to each other. So only one of them. What we need to, as just in wired communication, where we view a signal as simply a voltage waveform or a current waveform, in response to the transmitted signal, we can express the electric time t as. Okay, we are going to express the form in the form of electric far field f comma t r comma theta comma phi. Okay, why you write is that it is a cylindrical. Okay, cylindrical. So alpha s theta comma phi comma f of t minus rc divided by r. So where phi represents the point in space electric field is being measured. R theta phi. So you it as r theta and z in cylindrical and Cartesian, sorry, 3 different coordinates of the in electromagnetic fields unit 1, I think so. Okay, or the rectangular, cylindrical, and spherical. So 3 coordinates. Cylindrical, right? So here r is the distance from the transmitting antenna to the point in free space, and theta comma phi represents the vertical and horizontal angle from the antenna to the point respectively. Vertical angle is theta, horizontal angle. So there is a constant speed. So there is a constant called c, which is the speed of light. Okay, so almost all have been defined. So I need to define the alpha s. So alpha s in terms of theta, comma phi, comma f is the radiation pattern. Radiation pattern of the sending antenna at frequency. So f is your frequency. Radiation pattern is the amount of electromagnetic wave that antenna can emit per time is a radiation or per angle. So this also contains a scaling to account your antenna losses. So here you need to note that okay, the noting of sorry. So the equation 2.1 is far field at a particular frequency f with in a cylindrical coordinates. Okay, r comma theta s, which is the radiation pattern of the transmitting in the direction of theta comma phi into cos f of t minus r by c, where r is the distance between to the point where we want to manipulate or we want to calculate. Okay, so with that we proceed on to the next slide, which is determining equation number 2, which is 2.2. It is important to note since r increases, r is the transmitting antenna to the point where we want to determine. As distance increases, the electric field decreases by r power minus 1 by r, and thus the power per square meter in this wave will also decrease. Okay, if the electric field decreases by 1 by r, power will decrease by 1 by r square. So this is expected since we look at concentric spheres around the antenna. So this is the reason. So the through the sphere remains constant, but surface area increases by r. Therefore, the power per unit area decrease as 1 divided by r square or r power minus 2. 1 by r square is the reduction of power with distance. Then there are some obstructions to the free space propagation. This has to be. So now let us assume that there is a fixed receiver. We have a fixed receiver antenna at a location. The received waveform, considering there is no noise. Then we can write the equation ER received. You can see that E is at your transmitted. E 2.1. ER is your received. F comma at a point is equal to alpha theta comma phi comma f cos 2 pi f t minus r by c divided by r. Here alpha theta comma phi comma f is the product patterns of transmitting and receiving antennas in the given direction, in the direction of propagation. So now we are going to having a change in the electric field. Change in the electric field due to this movement of point U or option. Okay. So this is taken into account at the receiver. So which is h of f is equal to alpha of my f e power minus j pi fr by c divided by whole r, which is equation number 2.3. So then as er is your received electric field, er f comma t comma u is equal to h of f into e power j 2 pi f. We haven't mentioned it yet that both 2.1 and 2.2 are linear. So equation 2.1 and 2.2 are both in the input, but they are not at the output. The waveform will undergo distortions. Noises will be added. There will be losses of your signals. So that is the received field at a point U in response to a weighted sum of transmitted waveforms is simply the weighted sum of responses to those individual waveforms. Okay, at your receiver. So h of f is the system function for a linear time invariant channel, and its inverse transform is the impulse response. The need for understanding electromagnetism is to determine what function is, and we find in what way that the linearity is good solution for all the wireless channels that we had taken. Okay. So any queries in the free fixed transmitter and receiver antennas. You can type in chat box. Yeah, any queries till now? I think from my side, uh, I'm trying to resolve it. If any queries, you can type in chat box so that I can address you. Okay, no cool, nice. Okay, thank you, Atlanta. Okay, since most of you are not having any queries, okay, let me what understood from uh, 2 weeks from a small Q and so I'll give you the this or the questions in the chat box. Give me options. There are not more than 4 to 5 questions. Not more than 4 to 5 for this session. You can give me the answers such that also. So for all, it is not only for person X or Y. The question is for all. Everyone, anyone who knows the answer. Cluster, cluster. What is a cluster in a cellular system? Group of frequencies, group of cells, group of subscribers, group of mobile systems. Give your options. Your responses, I can able to trace out. Should. For each and every question, a 5 of time will be given. So try to understand fully and see the answers which is given. Then I'm able to see that answers are being coming out. So, are in a similar system is the question. I'm able to see being given most of people as B. Only 1, 2, 3, 4, 7, 8, 9, 10. Only 10 people has responded. Uh, another 4 or 5 minutes. Answers from the remaining people. They had thought. Let us see. And at last, I'll give you the correct answer. The answer for this question, what is a cluster in a cellular system? The correct answer is group. So Kirtana is correct. Yashwant is correct. Vaibhav correct. Kirti is correct. Meghala is correct. Deepthi is correct. Harita is right. Okay. Lokeshwar, the answer that you this group of cells, not group of frequency. Has given A and changed it to okay. Lakshmi Priya, Atlandeshwari. The answer is group of cells. B is the option. Correct. Manushya, B is the answer. Group of cells. Pradeep, group of cells is the answer. Okay. Atlandeshwari, okay, right. B is the answer. Credits to all those who had given the correct answer. Those are given. Don't worry. Try to get the answer for the second question, which I am giving. Okay. The question is again related to cellular system. What is a cell in a cellular system? A group of cells of subscribers, a small geographical area, a large group. Yeah, some 5 to 7 minutes of time will be given. Try to understand the question from the previous, then you can answer. Yeah, the correct answer for this question, which is what is a cell in a cellular system? It's a cell in a cellular system. The answer is a small geographical area. Rich given correct answers. Manasa Krishna, Meghla, Ravitija, Vinita, Sai Teja, Yashwant, Pradeep Reddy, Harshita, Navya, Deepthi, Velampalli, Malyadri, Manikilandeshwari, Lakshmi Priya, Kirti, Anusha, Durganaga, Srivalli, Kirtana, Hana, Pavan Kumar, Sharath. Credits to you all for giving the right answer. The answer is C, a small geographical area. Credits to everyone those are given correct answers. So from your answers, I could able to learn uh, very much interested and able to find the answer easily, and your understanding and at least something you are able to understand from my lecture series. Thank you all. Today only two questions. It's enough for today's question and answer session. So every session or have and a question and answer session at towards the end of session, such that whatever you had heard in lectures, if you are able to or two correctly, you might be also be satisfied, and I will also be satisfied towards the question and answer session. So today's admin sheet is given in chat. The link will be active till 4 p.m. today. Those who are filling this form only will be given attendance. So any other queries you can type in chat box.